Good afternoon everyone and welcome to the Debates and Insights channel. My name is Adrian and today I will share an insight on how you can harness computer science and the concept of prioritization to help you make the right decisions on matters such as when to stop looking for the house you want to buy or rent, selecting the perfect candidate, or even finding that special person in your life. If it's your first time here and you want to expand your knowledge on science, technology, education, culture, and entertainment and learn new insights that can help your personal and professional growth, start now by subscribing and clicking the bell below so that you don't miss anything. I'm actually currently facing one of the problems I referenced above. I'm looking to move into a new flat as our current lease expires in June, and we also need something bigger, as my partner and I just had a baby, if you remember, Jackie. So the two questions I need to answer are: number one, how many houses or flats should I see before making a call? If I spend too much time searching, hoping to find something better, I might lose the previous flat that I saw and liked, and if I decide to stop too early and select something, I might miss out on a better opportunity. Tough, right? Number two, how to prioritize between flats or houses. Which one is better? Is it A or B or C? It turns out that my first question is actually a form of the secretary problem, which puzzled a lot of minds in the 50s and 60s. The basic gist of the problem is as follows. Imagine you're a director or a hiring manager who wants to select the best secretary out of a number of rankable applicants for the position. Each candidate is interviewed sequentially in a random order. A decision is made immediately after the interview, and once a candidate is rejected, it cannot be recalled. During the interview process, the director gains sufficient information to rank the applicants among all the applicants interviewed so far, but is unaware of the quality of the yet unseen applicants. The question is about the optimal strategy or stopping rule to maximize the probability of selecting the best applicant. The difficulty lies in the fact that the decision must be made on the spot. It turns out that the answer is actually 37%. You see 37% of the applicants, and then you choose the first that's better than the ones you've seen before. This is also known as the look and leap rule, and it's scalable and remains true irrespective of the size of the pool, be it 100 or 10,000 people. Let's put this in perspective with my house debacle. If I have to choose between two houses, I basically have 50-50 chances of choosing the best. The second one might be better or worse, so I just might as well rent and brand them. But what if we add a third house to the equation? Theoretically, I would have 33% chances of selecting the best one. But can these chances be improved? Once I see the first house, I don't have any info to compare, and if I wait until the third one, it might be too late as I'll be out of options. The key is the second house. Once I see the second one, I shall know whether it's better than the first or not, and if I have rent it or reject it and move to the final option. This is the best strategy, as you'll end up getting the best house exactly half the time, 50%, which is better than a random choice, which would have yielded a 33% chance. As the number of houses grow, the chances of getting the best one, or looking and leaping, will converge to 1 divided by E, E being the famous irrational number equal to 2.71828, which equates to 37%. So after browsing through a website, I found a pool of 15 houses that I plan to visit, so using this rule, I should stop as soon as I see the first flat that's better than 6 of them, which is 37% times 15. So wish me luck, as today we're seeing the 7th one. Could this be the one? Now for the second problem, deciding if the 7th house is better than the rest that I've seen before. Well, here is a matter of prioritization. To say that A is better than B, you need to provide a proper justification or rationale that has an unbiased view. So you need to decide on a criteria what is actually important to you. In our case, we have 5 factors that will determine the decision: size, amenities, price, proximity to a tube station, which by the way is essential to get around in London, and the 5th one, extras, such as a garden. Yes, but it now begs the question, is price more important than size of the flat or the proximity to a tube station? We can solve this by weighting each criteria up and ensuring that it totals up to 100. For us, what we've done is proximity to transport is actually worth 10%, comfort in terms of size 20%, comfort as amenities another 20%, the price, which is rent plus council tax 30%, and finally the garden, which is an extra 20%, all yielding up to 100. Now all I need is a scoring mechanism to help rate each house against this criteria, where here we have to be as objective as possible. So if we opt for a 1 to 5 rating scale, I will score a 5 for the house that has the best time, i.e. shortest walking distance from the tube, and 1 for the worst time. The size of the flat can be measured in square feet, so I can apply the same rationale. Price, the highest price receives the lowest score, and so on. In the end, I will get a final score, which is rating times weight, for each criteria, and its sums will result in the overall score of the house. That's how I can tell if the 7th house is actually better than the rest. Thanks for tuning in. I hope you've enjoyed it, and I hope you'll start to look at these kind of challenges through an optimum stopping point prism. I am keen on hearing your thoughts on how you would apply the method, and also what other science methodologies have you applied in your day-to-day life to help make decisions easier. If you haven't done it by now, don't forget to hit the like and the subscribe button to ensure you get looped in on all the future debates and insights. Till the next time, remember to prove your existence by thinking.